11.5 areas of circles and sectors. Um, Formula you should know, area of a circle is area equals pi r squared. And now we can use this, just like we did with the area of arc length, we can set up to find the area of a sector. A sector is a part of a circle. Okay, it's not the full circle, but it's just part of it. So we can use the same idea that the part over the whole, the total degrees in a circle is 360. Um, and if I call, and then this would be the arc measure. So if we take the arc measure out of the total 360, that's going to equal the area of a sector of the sector to the total area. Total area of a circle is pi r squared. So same kind of proportion. This part is the same, but now instead of using arc length and circumference, we used area and area of a circle. Okay, find the area of the sector shown below. We're talking about this sector down here in red. Okay, what's the area of that sector? Well, we're going to set up a proportion. It's going to be 135 degrees out of the total 360. Okay, so basically it's 1/3 of a of the circle, right? This is 1/3, so 135 divided by 360. So whatever the area is, we need to find 1/3 of it. So the area of the circle is going to be pi times the radius 11 squared. And this is going to be the area of the sector. Let's call it A. So area pi times 11 squared, let's call that 121. So now I need to take 121 pi times 1 divided by 3. So we're going to figure out 121 pi divided by 3, because this is the area of the full circle, but it's only 1/3 of that area. And so that would be an exact answer. That doesn't get reduced, but we could approximate that to 121 times pi divided by 3. It's approximately 126.7 meters squared. Now make sure you're using the appropriate units. Okay, find the area of the shaded region. Now, so this is a little bit more difficult to find this shaded area. You know, this is an odd looking shape, but what we're going to do is we're going to find two different ways to do it. I guess I'm going to find the area of the circle. Try and get the eraser. Here we go. I'm going to find the area of the circle and then subtract the area of that triangle out. So the area of the circle is going to be pi times the radius of the circle squared minus the area of the triangle. If you find the area of this triangle, I'm going to look at the triangles inside of here. If I break this into the right triangle, okay, this central angle, it's going to be this angle here is 360 divided by, we have 3 of these isosceles triangles, and then that means 6 right triangles. So 360 divided by 6, this is a 60-degree angle. So if that's a 60-degree angle, this is a 30-degree angle, this is a 30, 60, 90 triangle. So using my special formulas, if this is 4, I know that's 2. And if this radius is 4, this radius is also 4. So I can figure out now this side length is the square root of 2 times the square root of 3. So this whole side length is 4 times the square root of 3. Got to double it. So 1/2 the base, 4 times the square root of 3, times the height, 2 plus 4, 6. So that's the area of the shaded region when I subtract that out. So cleaning this up, 16 pi minus 12 times the square root of 3. That would be the exact answer, centimeters squared, and we can approximate that. 16 times pi minus, minus 12 times square root of 3. 29.48 centimeters squared. Now, it's always good to make sure you know how to use your calculator, because sometimes doing this in your calculator, people get it wrong. So make sure you know how to use your calculator. All right, so this problem, you're cutting the front face of a grandfather clock. We want to know basically how much wood is going to be exposed. We want to know this. What is the area of that irregular shape? So we got to break it into shapes that we know. So I might first find the area of all this. Okay, no, it's not going to work very well, but the area of all that shape is going to be the total length from 10 up to 70. So it would be 80 is the height. The width is, this is 11, this is 10, so another 11 and another 10, so 22 plus another 20 is 42. The area of that whole rectangle is 42, but I got to subtract out this inner piece. Let me use a different color. This inner piece, the area of that is going to be 22 is the width, and the height is now from here up to there, which is 70. So that's the area of this bottom 3 pieces. Now the area of this circle up here, I'm going to find the area of the full circle. Okay, take this area, which is not a full circle, but it's half of a circle. So you could use that proportion method or just find the area of a circle and divide it by 2. So pi times the radius, it's not 11, but the full radius here is 21. So 21 squared, pi times 21 squared is the area of the purple part. Now the area of this part is going to give me just the wood part on the outside. So that would be minus pi times 11 squared. And now I have to add these 2 pieces together. And this gets a little bit big. I'm going to pause it and do my calculation. Alright, so I did some quick calculations. Did that calculation was 1,820. When I did this, I got 320 pi. So that would be the exact answer. And then I approximated that out to 814.69 inches squared would be the area of the full part. But notice how, remember, you got to find areas and subtract areas to find the total area of an irregular shape. Here's another example where you can find areas of shapes and then subtract them. I'm going to kind of just set this up a little bit, not do the whole thing, but I'm going to find the area of this piece. This piece is going to be, so we're trying to find the area of a countertop. This piece is going to have an area of 1.5 times 3. Okay, excuse me, this must be 3. Okay, and then I'm going to find the area of this piece. Notice that's bigger than the actual countertop, but if this is 3 and this is 1.5, it's going to be 4.5, and it's a square, so I can just square it. But I have to subtract out, let's use yellow, I'm going to have to subtract out this piece here, which would be minus, that's a quarter circle, so minus 1/4 the area of that circle, pi times the radius, 1.5 squared. That's going to tell me the area of that piece. I'll have to add to it the area of this rectangle, 3 times 2, then the area of this semicircle, area of this semicircle is going to be a half circle, so half pi times my radius. Radius here, if this whole thing's 3 feet, it's 1.5 squared. Okay, so add these things together, add those parts together, and you can find the area of the total countertop. There's your homework assignment. And I can't stay Blue Jay.